Hi, this is Victor Gamov with Confluent, and in this exercise, I'm going to show you how you can use Cloud Schema Registry together in your Spring Boot application. So let's get to it. And we're back to our application that we developed on the previous lesson. And in order to use Schema Registry, we need to make sure that the Schema Registry is activated in our Confluent Cloud. So go into Confluent Cloud in my environment and I find the Schema Registry. I should be able to see something like this, like endpoint that I will be able to connect to, and some of the keys that I will be able to connect my client application. We'll get back to those in a few seconds. Next thing is that we also need to use a plugin that allows us to generate a Java POJOs out of Avro schema. So in this case, we're going to be using this Avro Gradle plugin. We're going to copy this piece in our build script. So we'll go into the build.gradle, find the section about plugins. In order to this to be activated and used correctly with my IDE, I also need to enable IntelliJ IDEA plugin. So I will refresh the configuration, and how I would know if this actually works, I should be able to see a new task here very soon, like after a few seconds when the Gradle will be updated, called source generation. All right, in order to generate our Java POJOs, we need to create a Avro schema, which we will be using the JSON format for the schema. Go in here, insert C main, and we can create new folder called Avro. And inside this Avro folder, I will create a file called hobbit.c. So in this case, we're going to be using this schema that represents this Hobbit object that will be holding one property called quote. So we're going to store our string that was generated using the Faker library, and after that we'll wrap this into Hobbit object. So in order to get this working, I need to go and execute a Gradle task called generate Avro Java. And what I will see here in my build directory, I will see this generated main Avro folder with my object Hobbit. And because I enable IntelliJ IDEA Gradle integration, it was able to modify IntelliJ IDEA project and also include generated sources in the class path. Now let's modify our application code as well in order to support this. Also, couple dependencies that we're missing here. So first of all, we see that it was generated some code, but some of the things are missing. So this is why we don't have our Avro dependencies. We will fix that in a second. Now, we're going to be using Confluent provided serializer for our application that will be using this Avro object and serialize it and store information in the schema registry. So in this case, we're going to be using Kafka Avro serializer in the version of Confluent platform, also aligned with the version of the Kafka that Spring brings. So in application .properties, what we need to change now, and we need to specify this special serializer called Kafka serializers and our Kafka Avro serializer. And at this point, we're done with our producer. Let's fix our consumer. So in our consumer code, so first of all, we're going to be using different topics. So let's call it topic Avro, Hobbit Avro. And we're going to be listening topic called Hobbit Avro. In this case, our string becomes integer because our key is integer type, and our value is Hobbit here as well. So that's our consumer. We don't need to use a processor, so that's why I just commented out these annotations. So those methods wouldn't be created and the REST controller as well. So just in case, because we don't need this for now. Now, our producer now supposed to be creating messages in Avro format and write these messages into Kafka topic. So let's create this new Kafka topic. We don't need this guy actually here, and let's call it Hobbit Avro, and we will provide a name Hobbit Avro here as well. Before I run this application, I need to copy one important thing from our Confluent Cloud config. So let's get back to Confluent Cloud and switch into these clusters, my cluster. We're going into clients and Spring Boot. And now what we can see here, we can generate our schema registry key and the password. Let's call it Spring Kafka lesson. We're going to save this, continue. So in this case, my placeholder was replaced with actual values. That's something that I will copy in my code, in my configuration. So I'm going to application.properties, and somewhere here around these lines, I should put this configuration for schema registry. Couple things that we put this extra. It's a schema registry URL. This is the location of our endpoint that is connected to our Confluent Cloud cluster, and some of the authentication properties, basic of user and the type of credential source. After I modify the code for my Kafka consumer here, I also need to change a configuration for my consumer. So in this particular case, my consumer was using a long and string serializer, deserializer. So in this case, it's going to be using integer deserializer, and it will going to be using io.confluent.kafka.serializers and Kafka Avro deserializer. So in this case, my producer will produce data in Avro format, and my consumer will consume data in Avro format. So what I will do here, do not forget to disable Kafka streams here, because we don't need this for now. We didn't modify this code. And once again, our producer writes data into topic in a Hobbit format, and our consumer also does the same. All right, so let's run this. And what we start seeing here is our system out println start writing data in Avro format. So let's see if we can see the same data in our topic. I'm going here, topics, Hobbit Avro, messages, and voila. Now we are able to see something like this. So value would be stored in Avro format. Again, UI is not fully show this. However, we now can see inside our topic in the schema tab, we finally can see our schema. We can see the version of the schema. We can modify the schema and so far and so on. And now you have it. In this lesson, you learned how you can use Avro format and how you can connect Cloud Schema Registry in order to produce and consume some of the binary data and use this for more complex objects that you might have in your applications.